हरिः कर्ता।
Now it's time to deep dive into various techniques that we can use to do the data cleaning, such as remove or handle missing values in the data set, handle outliers and anomalies, then dealing with duplicates and inconsistent data, dealing with the duplicate or redundant data, and finally normalize or standardize the data if necessary. So what we're going to do is now, so we will start with handling missing data. There are two ways. The first one is data imputation, second one is deletion. First we will see data imputation techniques, all data imputation techniques, each data imputation techniques in detail. Then we will go to deletion techniques, then outliers, then dealing with duplicates, and one by one. That's what we're gonna see. And now let's look into the first technique under data imputation, that is mean, median, mode imputation. So in this technique, missing values are filled with the mean, median, or mode of the available data. So this is a simple method that can be used for numeric or categorical data, but it does not take into account any underlying patterns or relationships in the data. So that's the pain point of using this mean, median, or mode imputation method. So if you want to understand this well, first you need to understand the understand what is mean, what is median, and what is mode. So to understand this well, I just want to take you through a small example. So let's consider this problem statement. So we have a data set which consists of number of wickets taken by Bumrah in last 7 games, and these are their data points in respective days. Seventh game 2, sixth game 3, fifth game 1, fourth game 4, fifth game 5, and sixth game 6, and then again and the first game is 2. Okay, so this is the latest one. Seventh game 2, then sixth one is 3, fifth one is fourth one is 1, fifth one is 1, and fourth one is 4, third one is 5, and second one is 6, and first one is 2. That's the respective wickets taken in the respective cricket matches by Bumrah. Now I want to know what is the how much are the average wickets he has taken out of all 7 games, on an average number of wickets taken by the Bumrah. To calculate that, we can use mean. So mean is nothing but the sum of all data points divided by number of data points. I have 7 data points, and sum of all data points is equal to 2 plus 3 plus 5, 10 plus 4, 14 plus 6, 20, and then 20 plus 1 plus 2. That's what my sum of all data points. Then we have number of data points, which are 1, 2, 3, 4, 5, 6, 7. So sum of the data points divided by number of data points will give the mean. That by and large I got 3.2. So as wickets are discrete, so I have rounded off to the floor. So 3 wickets. So Bumrah has taken 3 wickets on an average on in every match. Okay, so now, so another measure to find out this same information is median. So median, if you want to use the median, first thing you have to do is you have to sort all your data points. You have to sort and arrange all your data points in lowest to the highest value. So this is how I did: 1, 2, 2, 3, 4, 5, 6. Okay, this is the sorting order I did it. Now if you want to calculate the median, let's take if total number of data points, that's n, is odd, then it's pretty simple. The formula for that is n plus 1 divided by 2 observation. So n plus 1, in this case 7 plus 1 divided by 2, that's nothing but 8 by 2, that's fourth observation. What is my fourth observation here? 1 2 3 fourth. So my median for this data set is 3 wickets. You see that it's a 3 wickets. Let's take, in spite of going for the 7 games, we have gone for the 8 games. Then how will you calculate? Let's take in 8th game, he has taken 1 wicket here, somewhere here 1 wicket. Then 1 1 2 2 3 4 5 6. So one more one, I have to put one more one here. Okay, so now to calculate the median, this is the formula: n by 2 plus n by 2 plus 1 divided by second observation. So in that case 8 by 2 4 plus 8 by 2 plus 4 plus 1 5. So fourth plus fifth observation divided by 2. What is my fourth observation? So 1 2 3 fourth 2 plus, and fifth observation is 3. 2 plus 3 5 divided by 2, 2.5 wickets. As it is discrete, I will make it up to either a floor or ceiling. So that's how we calculate the median if total number of data points are odd and total number of data points are even. Then the next technique that we have here is mode. To calculate the mode. The mode of this data is 2 wickets, because now the most occurring data point is known as mode here. Okay, this is the most occurring data point in this. It's a 2 wickets. So this is how we summarize our data set. So on an average, using mean, he has taken 3 wickets, using median 3 wickets, using mode 2 wickets. Got it? Now let's take one example. Now using these methods, let's apply data imputation. So mean, median, mode imputation. So let's import pandas as PD. Now let's create a sample data set. Create a sample data frame with missing values. So df is equal to PD dot data frame. Inside that, first we'll begin with A. Let me put 1 2 and none, 4 5. Then second one, B, none, 2 3, none, 5. Then the next one is C. This time I'm gonna go for A, B, none, sorry, D and none. So where is that issue? Okay, so this is my data frame df. Okay, so I have the 3 columns A, B, C. One is, 2 are completely no, numeric, discrete, of course they are, and other one is categorical. So before we do this, before we apply a mean, median, mode imputation, I just want to explain one more thing. So that's this. So mean median mode imputing. Impute nan using mean median mode. So the absence of data reduces statistical power, which refers to the probability that the test will reject the null hypothesis when it is false. We know this logic. So that is the reason we want specifically this imputation technique. The lost data can bias in the estimation parameters. So to solve these issues, we want to go for the imputation. So in that we'll see mean, median, mode imputation. So it's always recommended to impute missing values with appropriate substitution. So what is that appropriate substitution? That's what we'll be seeing here. Okay. So this data, for example, NAN or asterisk hash name or NA or a minus triple line, these are all considered as a missing values or empty one. So now the possible techniques using mean, median, mode are is specifically used for the following categories: numerical and then categorical. Now for the numerical, so when to use mean for imputation, that's what the first task we'll be seeing here. When to use mean for imputation. So the missing data can be filled with the mean of columns values with if the case is the data is roughly symmetric in normal distribution or less skewed. That's the case one. That's what I'm saying. First we will look into the mean one. Mean, if the data is numerical and if it is no skewed or less skewed, then we can use this mean. And the case 2 is even though the data is somewhat skewed with outliers and we need the outliers for the model, in that case also we can go with the mean. So in these cases only we have to use mean imputation. Okay, I hope you got my point. I'm repeating this again. There are two cases I will write down for the mean, then we will do the mean imputation. So mean imputation. So case 1, the data is roughly symmetric in normal distribution or less skewed. And case 2, even though the data is somewhat skewed with outliers and we need outliers. If we need outliers for the model, specifically for the model, then we need to go for this uh, mean imputation. So example, income outliers may exist, but the income is too high in certain cases is also true. So that's what I'm telling. So in these cases, so income outliers may exist, but the income is too high is also true in most of the cases. So that's the reason if within these two conditions you can go for the main imputation. Okay, so now let's get into the example of main imputation. So we have our data frame. Now to do the main imputation, simple. Let me take the respective column. Of course I need to go with this numeric values, not categorical variable. So I'm gonna give fill NA. I'll use fill NA method. Fill NA method, and then so using DFA. So capital A, and this is the column, and I want to do mean of it, and then in place. I want in place. That's it. So we have used the fill na, and the first argument is uh, aggregating the mean, aggregating the column, respective column, and then second is in place. True, I want it in place. And now let me check, and here is that the mean imputation is successful. Okay, the mean imputation is successful. Let's take one more example, this time a real data set example for the mean imputation. So I'm gonna go for customer segmentation data. Cust is equals to pandas dot read csv customer buying pattern. No, customer segmentation is on top. So cust, and this is 2000 rows column. I think other one, data transformation. Okay, customer buying pattern. No, I got it. So the data is um, unit sales data. Yes, this is what the data. So now because of some reason they are unable to units, and okay. So anyway, uh, months. Let me fill the months first. Months could be just a series. You can fill it in a series way. That's what, based on the nature of that variable, you have to fill it up. In this case, what I want to fill is mainly, I see all are numeric variable. So this is price is my continuous variable, add expenses is continuous variable, prom expenses are continuous variable. So first I will target the price, and after that the other one. So cust, sorry, units, and in place I want it for price first, and then I want to use fill na method, and this gonna take two arguments. First, a mean of that, so units, and again price, and its mean, and second argument as usual in place. Second argument is in place. Let me check this directly from here. So mean has been added, then okay, there is some issue. Let me sort this out first. Yeah, done. Okay, it got slowed down. Yeah, now it's done. So now let's check units, and here is that. Here is your mean imputation. See that the values has been replaced with the mean imputation, and the same thing can be applied to the other columns, which is add expenses, and units, and here it is. You got the add expenses values also. That's it. So this is what is mean imputation.